Okay, let's spend a couple minutes talking about distance on the coordinate plane, and that's the distance between any 2 points. And what you'll see is we can use the Pythagorean theorem to do that, and then we can turn that into a formula called the distance formula that's really easy to use. Okay, so first let's set up some points here in order to figure out how we're going to use the Pythagorean theorem. So what I've done is I've set up 3 points here, D, E, and F, and you can see the coordinates right there. And let's first ask a question. What's the distance from D to E? So you can just, if you want, you can count on the coordinate plane here. It's 1, 2, 3, 4. And that's a fine way to find that distance. We can put that distance in there. But another way is to realize, well, that's just the difference in the x values of 6 for E and 2 for D. And 6 minus 2 is 4. So we can write that up here. The distance D to E is 4, which is equal to 6 minus 2, the difference in the x values. Okay, now let's ask a different question. What is the distance from E to F? So we're talking about this direction here, and we can count this out. 1, 2, 3, 4, 5, 6, 7. So that would be one way to do it. We can go ahead and write that in. But an easier way would be to realize that here we're not talking about the difference in the x values like the other distance, but we're really talking about the difference in the y values. The y value here is 9, the y value here is 2, so the difference is 7. 9 minus 2 is 7. Okay, so let's go ahead and write that in. So the distance E to F is 7, which is the difference in the y values, 9 minus 2. Now, what we're really after here, though, you might have guessed, is what is the distance D to F? That you can't just count up the squares because it's on a diagonal, and you can't just subtract x values or y values, so that's a little bit more difficult. But what you're probably seeing there is that that makes a right triangle. And we know that with a right triangle, we can use the Pythagorean theorem. So let's go ahead and set this up. We can say that 4 squared plus 7 squared equals c squared, okay? Remember the Pythagorean theorem says a squared plus b squared equals c squared for any right triangle where a is a leg, b is a leg, and c is the hypotenuse. So what we've done is just basically use the Pythagorean theorem here. Now we can do a little bit of arithmetic. 4 squared is 16, 7 squared is 49, so let's go ahead and write that. We'll get the c squared on the left-hand side so that we can be solving for that. Now we can add 16 plus 49, a little mental math. You can see that that's 65, so c squared equals 65. At this point, you probably want to use a calculator. Take the square root of both sides, and the square root of c squared is just going to be c. And the square root of 65, according to the calculator, is 8.06226, and it keeps on going. And then we go ahead and round this to some sort of reasonable amount. The problem didn't tell us exactly what, so we'll go ahead and round it to the 10th place right there. Okay, so by using the Pythagorean theorem, what we've actually done is find the distance between 2 points that weren't right above each other or right side by side, but we can use it to find diagonal distances as well. So now we're really cooking because we can find the distance between any 2 points then. Now, we don't always want to set up a right triangle to find the distance between 2 points. So let's see if we can turn this situation into a formula that we can use more easily over and over again. Okay, so I'm just going to put a coordinate plane here, and I'm going to put 2 points, and let's ignore where they are on the grid, and let's just label them x1, y1, and x2, y2. Okay, we're just going to put those as kind of generic values there. And what we are going to do is we're going to go ahead and try to find the distance between those 2 points. Whatever x1, y1, x2, and y2 are, we're going to find that distance, okay? Now, let's go ahead and figure out that we're also talking about a right triangle here. We don't have to figure this out every time for the formula, but to define the formula in the first place, we're going to go ahead and create that right triangle. And that lower distance, the distance right here for this leg, what would that be? Remember now over here on this side, we saw that this distance here was the difference in x values. So is this distance here. So we're going to go ahead and put the difference of the x values as that length, x2 minus x1. Make sense? Okay, now what about this leg here? What's the distance there? Well, that's the difference in the y values, just like we were doing earlier on the other side. So now we can set up, using the Pythagorean theorem, we can basically say a squared plus b squared is going to equal c squared, but instead of a, b, and c, we're going to put in these values here. Okay, so it's going to look a little bit long, but we have x2 minus x1 squared plus y2 minus y1 squared equals d squared. Just our Pythagorean theorem. Now, what we're really after is the distance. So when we have a formula, we want to solve that formula for that variable. So we want to solve this for d. So first, let's go ahead and switch it around. So we get d squared on the left-hand side. Everything else is just the same here. And now, how would we solve for d there? Well, we're going to take the square root of both sides. So if we take the square root of both sides, on the left-hand side, what we're going to try to do is just get d by itself, which taking the square root will do. So let's go ahead and write that. We have d equals, and on the right-hand side, we can't really simplify this any further. So it's d equals the square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. And in fact, that right there is the distance formula. So what you can do then is you can say any 2 points, x1, y1, x2, y2, I can put their values, their coordinates, into this equation, or this formula here, and then I can perform the arithmetic and I can get the distance between those 2 points for any 2 points on the coordinate plane. So let's go ahead and find the distance between 2 points. -1, 6 and 2, -3. We'll go ahead and call this x1, y1, and this x2, y2. You could switch them around, you'd get the same answer. Okay, let's go ahead and put those values into our formula. So d equals x2 minus x1, so that's 2 minus -1, 2 minus -1, all that squared, plus y2 minus y1, -3 minus 6, all that squared. See how we're just substituting the values that we have over, or for the values into the formula that we have over here. Now we do some arithmetic. So 2 minus a -1 is 2 plus 1, or 3, so that's 3 squared. And -3 minus 6 is -9 squared. Okay, now we'll go ahead and square those two things. So 3 squared is 9, and -9 squared is 81. And now we'll go ahead and add those up. So we have d equals the square root of 90. At this point, you probably want to use a calculator, and we can get d equals 9.4868, and the calculator answer will likely keep repeating in many cases. And let's go ahead and just round this to the 10th. So we have the distance between those 2 points as 9.5. So here we have an example where we're just given 2 points, and because we have this great formula, we can find the distance just like that, and it's really just a matter of plugging into the formula and doing the arithmetic. And you can use that with any 2 points.